Hello all, welcome back. In this session, we are going to see about bagging and random forest in machine learning, as well as boosting too. Credits to NPTEL, online resources, and many more. So, what's the problem in decision tree? So, in decision tree, it tends to overfit. It has low variance, it has low bias and high variance issue. So, our target is to reduce the variance. So, for that case only, we are getting into random forest. And before getting into random forest, we need to see what is meant by bagging and how you are going to overcome the decision tree problem that is tends to overfit. Normally, we will do pruning. Pruning helps reduce variance to a particular point. But with the help of pruning, we are not going to overcome the entire issue. Anyhow, in order to overcome that, we are introducing the concept called bagging. So bagging by mean train multitude of decision trees. For example, just for two decision tree, see here 4, 8, 16 and so on. We train multitude of decision trees and combine their predictions to reduce the variance. Our main target is to reduce the variance, that is sigma square. So that how to train the multiple decision trees? We grow decision trees from each bootstrapped sample. See here on left hand side there is a data set with 14 rows. Assume there are 14 rows. Out of that 14, 2 by 3rd 2 by 3rd of the data set is given to first decision tree and remaining 1/3 is left out. Same way, in second for this second decision tree, I am going to give the remaining 2/3 of the data set. It may be a repetitive one too. Kindly make a note of it. At the top and at the bottom, few data points are missed out. Out of 14 data points, 14 rows, in top 3 and bottom 1, out of 14, only 10 data points are used. Right? And same way for next decision tree, the next set of data set is given. And the decision tree is tuned. Right? How we need to aggregate those results? For example, in previous case, we have seen 3 decision trees. Same way. Out of those 3 decision trees, right? First decision tree gives a result as brown, and second decision tree predicts a class as brown, and third decision tree predicts as blue. We need to do a voting mechanism over here. Out of this 3 thing, which one has highest majority? Has the highest majority is brown. So you are going to write it as brown. It is called aggregating the result. Same way you have n number of decision trees, right? For all the decision trees, for example, in second class, see here, you have 3 decision trees. Out of these 3, 2 decision tree predicts classifies it as a blue, and the second one as brown. So while you are aggregating the result, it will be blue. Same way for third case, see here, all the results are brown. So while aggregating the result, it comes as brown. So as a result, the aggregated results, if you take, brown wins and blue is with 6 and brown is with 7. So this is called bagging. In other words, bagging is otherwise called as bootstrap aggregating. Bootstrap aggregating. Now, in each data set, we have there is some 1 by 3rd of data that is unused, right? That unused data sets are collected together to form a create a tree and measure error for the particular tree on unused samples. Right? Let me repeat. For each data set, we have used only 2 by 3rd of the data, and remaining 1 by 3rd of the data is unused data. But the unused data of each decision of data set create a tree based on the subset of data and measure error for that particular tree on unused samples, and that error is called as out of bag error. OOBE error. Out of bag error. What's the purpose of out of bag error? It is used to calculate the feature importance. Out of bag error is used to calculate the feature importance in a particular data set. Now, bagging performance increase with more number of trees. Yes, of course, when tree gets increased, the bagging performance gets improved. But make a note of it. After 100 iteration, that is a number of bagged trees 100, the RMSE remains same. It constant. It is constant. Root mean square error is constant. So maximum as per the research study and as per previous literature review, you can have maximum the decision tree number of bagged tree as 100. And what's the advantage of bagging? It is easy to interrupt and implement. Heterogeneous input data is allowed. No pre-processing is required. And the main merit of bagging is can grow n number of trees in parallel and less variability than decision tree. And what is meant by random forest? So in what way this random forest is differ with respect to bagging? Yes, in step number 2 and step number 3 the random forest varies. So random forest is a combination of many decision trees, bagging, random forest feature selection, and finally it's a sum of majority voting. It's a combination of all those things is called random forest. In other words, random forest is an ensemble learning method. It is best used for both classification and regression tasks. They combine n number of multiple trees to improve the overall performance by reducing the overfitting issue seen in individual decision trees. It is overcome in random forest. What are the steps used in random forest? Step number 1, randomly sample k cases from the dataset for training each decision tree as the decision tree. And step number 2 and 3 varies. In step number 2, select m features from p available features. Let me assume you have p available features, p number of features. Out of the p number of features, we are going to choose only m features. In numerical term, if there are 5 features, 5 input features, we are going to choose only 3 features at each node. And step number 3, grow each tree as deep as possible without pruning. We are not going to prune any data, right? And step number 4, for each new data point, each tree gives a prediction. So for that prediction, each tree gives a prediction. And step number 5, we are going for voting or averaging to decide the final prediction answer. This is how it will works in random forest. For example, you have a number of fruits, collection of fruits in a particular root node. That root node is classified into a number of trees. For example, tree 1, tree 2 and tree n. For example, the tree 1 classifies it as an apple. Same way, second tree, decision tree, classifies it as an apple. And a tree n, it classifies it as a banana. So it is class B. So after aggregating their measure by putting a voting, so which one wins? So class A, that is apple, is higher compared to banana. So apple wins. So considering final apple as your final class. In random forest, as I said earlier, it is equivalent to bootstrap sample. So out of n number of data points, we are going to consider 2/3 of your data points in step number 1, right? And remaining 1/3 of the dataset remains unused. And step number 2, it reduces the correlation. Why we are using only p samples? Out of p samples, see here, out of, in this case you have 1, 2, 3, 4 and 5 sample, 5 and 6 samples are there. Out of 6 samples we have considered only 4, right? So we are reducing the sample so that it will reduce the correlation between the trees. That's the main beauty of random forest. That's why in many projects we are going with random forest. And this random forest is a commonly used machine learning algorithm projects. So what is meant by boosting? So boosting, what we will do in boosting means the model is developed by connecting n number of weak models in series. Boosting is an ensemble modeling technique that attempts to build a strong classifier from the number of weak classifiers. If you have n number of weak classifiers are connected in series, so that outcome of the weak classifier becomes a strong one. First, a model is built from the training data, and then the second model is built which tries to correct the error that is present in the first model. Same way, the second model is developed. The purpose of the second model is to reduce the error that is produced by the model number 1, so that same way it prolongs till n number of models, so at last the classifier efficiency becomes strong and accuracy gets improved. This procedure is continued and models are added until either the complete training dataset is predicted correctly or maximum number of model is added. The pictorial representation of this boosting is given here. First, the model is developed. The output of first model is given as an input of the second model. The error in first model is reduced in model number 2. Same way, the is called boosting. The pictorial representation of boosting is given here. The model 1 gives some error. That model 1 error is given as an input to model number 2, and model number 2 trains that particular error and reduces that error and gives that error as an input to the next model. Same way, at the end, the model accuracy gets improved. Fine, this is called boosting. In this session, we have seen what's meant by bootstrap aggregating, and otherwise we call it as bagging, and what's meant by random forest and boosting. Thank you all.